Good day everyone. Today we will talk about a hash table. A hash table is a collection of a key value pairs. Each value pair is known as entry. We have two pieces of data here. The first is key and the second is value. In this example, the key is integer and the value is string. So, how do we know of which index place of this entry? Well, what we could do is take its key and insert it into a hash code method. The hash code method will take a key input, plug into a formula, split out an integer. This integer is known as a hash. Now, if we're finding the hash code of the integer in Java, the formula is the number itself. So, the hash of 100 is 100. 123 is 123. So on and so far with the other key. So after finding the hash of your key, now what we do, each number are with so large and the size of our hash table is only 10 element. What would we do next is take of these each hashes and divide each of them by the capacity of the size of our hash table. We have 10 elements, so each hash divided by the capacity of our hash table. Wherever the remainder, we will use the remainder as an index. And to find that, we will use the modulus operator. So 100 divided by 10, the remainder is 0. So the SpongeBob entry, we will place at index 0. So the hash of Patrick K is 123. Then 123 modulus to 10, the remainder is 3. So Patrick entry is placed in index 3. And now the hash of Sunday K is 321. So 321 modulus to 10, the remainder is 1. So Sunday entry is inserted at the index 1. The hash of Squidward entry is 555. So 555 modulus to 10, the remainder is 5. So Squidward entry is placed at index 5. And the last is Gary. The hash of Gary is 777. So 777 modulus to 10, the remainder is 7. So Gary inserted at the index 7. So there is a code here and I will explain it line by line of how the code will work. The first line is package hash example. This line declares that the class belongs to the package name hash example. Package help organize classes into namespaces. Next, public class hash example. Define a public class name hash example. This is the main class of the program. Then the public static and polynomial hash string key and in. Define a static method named polynomial hash that take a string key, takes an int, return an integer. The next is int p equals 31. So this line sets a constant multiplier p used in the polynomial rolling hash formula. 31 is a common choice because it helps distribute hash value more evenly. Int hash equals 0. Initialize that hash value to 0. This variable will store the computed hash of the key. N power equals 1. Keep track of powers of p. Starts at 1 because p to the power of 0 equals 1. To this loop, for int I equals 0, I is less than k dot length I plus plus. It loops through each character in the string k. K dot length returns how many characters are in the string. And char value equals k dot char at. It will get the ASCII value of the characters at position I using char at I. hash plus equals char value times power. Update the hash value by adding the character's ASCII value multiplied by the power of p. This implement the polynomial rolling hash formula. Power times equals p. Increases the power of p for the next character. Example 1, 1 to 31 to 936 to 29,791. The next is return hash modulus to n. It will return the hash index by taking the hash value modulus to n. This ensures that result fits within the hash table size from 0 to n minus 1. So the main method is public static void main string args, the starting point of Java program. So string key1 equals dog, then string key2 equals cat. Defines two strings case that will be hash. Int n equals 10. Sets the hash table size to 10. Prime number is usually chosen to reduce collisions. Int index 1 equals polynomial hash k1 dot n. Int index 2 equals polynomial hash k2 dot n. It calls the polynomial hash method for both strings. Index 1 and index 2 store the hash index results. So system out println k plus k1 plus. So this line prints the result showing its k and its corresponding hash index. Example, the outpost is k dog, and the dog is in index 4 and the cat is in index 3.